Okie dokie, we're all good, huh? No, you need to use English. Huh? They're different, yeah.
Who's Yankee?
The bomb.
Yeah.
The bomb?
Yeah.
Bomb.
Bomb?
It will describe the
Yeah. Electronics.
Yeah.
The TNT. I only know TNT.
More advanced than TNT. More advanced. Alright, potential divider now.
Only one lesson?
Only one lesson, and then we can do a tutorial. If were some of the questions difficult, I don't know.
Wait, so we don't have a review plan?
Oh yeah. We can start review if you like.
That's better.
Okay, we'll do that after potential divider. Yeah? No, stop, please. I want only English.
So some secret.
Don't be saying secrets in class then. Oh, come on, Summer, you got your pen. You got your pen. Now, easy lesson. Potential divider.
The feeling is like the start of the school. The first, only me and Ben, the two person here.
Yeah. Okay. Right, now look at this circuit here. So, this circuit here is the circuit for what's called the potential divider. So, it has a few parts. The first one is you have an OR2. You see that? And here you have an OR1, but you can change the OR1. Okay. And here you have a voltage. We'll call this one V in. And we'll call this voltage V out. So this is like V1 and this is V2. Now what I want is, I want the formula for V out. So if I use the loop rule, okay, V in minus IOR1 minus IOR2, that equals 0. That's fine, okay. So you can rearrange this to say I equals V in over R1 plus R2. So we know the I here. Now how can I get the V out? Yeah, I can say V equals I R2. So I can say V out equals I R2, which equals this. Yeah? So I have a formula for V out if I know V in and the ORs. So what I need you to do is write all of this down, including this little proof.
Okay.
Good lunch?
Oh, yes.
What did you have? What did you have?
Oh, somewhere.
Subway. You could have taken it to class, no problem.
Nice smell.
I like Subway. It smells nice. What did you get on it? What did you put on it?
Cool.
Yeah, what did you put on it?
The subway.
The sandwich. What did you put on it?
Oh. Onion.
Yeah, onion's good.
Turkey.
Turkey's good.
And potato corn.
Potato corn?
What's potato called?
Eating corn.
Corn.
Yeah.
Yellow.
Oh, yeah.
Yeah, just corn.
And potato.
And potato? Are you sure?
Tomato.
Tomato.
Oh,
Not potato. That's different.
Sounds like.
So way in is the battery.
Yeah.
So what's the meaning of the title?
Yeah. So potential means like PD.
Yeah.
Remember we did PD yesterday? PD?
Oh,
Do you remember?
potential difference.
Yeah.
Okay.
And what's potential difference?
Voltage.
Yeah. So what this does is it divides the voltage. So you have a voltage that goes in and you have a different voltage here. This voltage is not the same
Yeah.
as this voltage. They're different. Okay. So what a potential divider does, to answer your question, Summer, the potential divider allows for the input voltage to be reduced. So for example here, oops. You can see the R1 you can change, yeah?
Yeah.
If you make the R1 0, then what does V out equal?
IR2.
Try again.
IR2.
I haven't looked at this.
Vn.
Vn.
Yeah.
So if this is 0, we get Vn equals V out. Now if you make this bigger, if you make the R1 bigger, what happens to V out?
Small.
Smaller. So it reduces. So by turning the R1 up, you can make a smaller voltage. So the potential divider reduces the voltage. The output voltage can be found from this formula. Now this is important because, for example, you see this here. This voltage is 220. But this voltage only needs like 6. So you need some way to reduce the voltage down. Yeah? And this is a very simple way to do it. Now in real life...
That things.
Huh?
That things.
No. In real life we don't use this circuit because it's not efficient. You know efficient? Remember efficient? Efficiency?
Sorry.
Okay. No, don't stop. Efficiency.
Oh, yeah, I know.
See?
But I don't know what's this. I missed this class. I don't know.
Okay. So, but for a small, something like a toy, like a little children's toy, something simple like this, you could use the potential divider to change the voltage. You just have to change the R1. Okay. So the definition is the potential divider is a circuit that allows for the input voltage to be reduced. I think you should write that down with this formula, which you should have.
So that's like the lights. We can change.
Yeah, it's like that, yeah. In fact, I think you're right, Summer. I think this, in a light switch, they use this. They use something like this, I'd say, yeah. You got that? You got that? Yeah.
Sorry.
Summer? No? How's the cat? Great?
He like sleep 20 hours per day, and he only
That's like Summer.
like play around the room while he sleep.
Okay.
It's,
It's a lazy cat.
yeah.
Oh, I'm bound not to.
Alright, continue? Yeah. Right, so here's our example. You have a circuit and you need 11 volts. However, the main supply is 220 volts. So you have 220, but you want 11. Okay. You have a 10 milliohm and an X milliohm resistor. So what I mean is, in the picture here,
Or what?
this one is the X and this one is 10 milliohms. Okay? Right, so my question is first to draw the circuit. Okay, that's fine. You have that picture there. Find the X. Okay, I'll let you try. Use your new formula. See, can you give me the X?
use new formula?
Yeah.
I think the loop through can use.
Yeah, same thing. Same thing. Big sandwich or small sandwich?
Big.
So you're not hungry.
Oh.
No.
20 over 11.
What is it?
20 over 11.
20 over 11 milliohms. Yeah?
Yeah.
Are you sure? Yeah? So if we use the formula, what's or out?
What?
V out is 11.
No.
Yeah.
And then V in is 220. Yeah?
Yeah.
And then this is R1 plus R2,
Yeah.
which is x times 10 to the minus 3 plus, what's the other one?
Oh, sorry.
No, you'll see.
10 million.
10 times 10 to the minus 3. And on the top here is 10 times 10 to the minus 3. But they all cancel. So you get 11 equals 10 over x plus 10 times 220. That's 220.
Oh.
Yeah?
Oh, yeah.
Isn't it?
Oh.
Ah,
It's 00. 2200.
2200. Thank you. So then you get x plus 10 equals 2200 over 11, which is 200. Yeah? Is that right? So then x is actually 190. So, or...
Well, I got point 19.
Huh?
I got point 19. 0.9.
Yeah, no, yes, but that's correct, yeah, because x is... So R2 is 190 milliohms, or you can say that's 0.19 ohms. So you must have said this.
Because I didn't.
But you have to be careful because I said what's the x? And the x is milliohms. So actually, this is what x is, which is what I wanted. Is okay?
Yeah.
Okay, let's continue. So next now, what's the current? Alright, so you can use your VI or V over R. So the current is 11 over, I want the current here, over R2, not R1, sorry, that's R1. 11 over R2, which is 11 over 10, which is 1.1 amps. Okay?
We use million?
No, I just for this question I did. Oh, that 11? No, that's the volts. 11 volts.
So we don't have.
We didn't need the X for this one.
Yeah,
Yeah.
and we don't have to convert to ohm from 10. So the volts can divide. Like
This 10. Thank you. I forgot. It's not 10, it's 0.010. You're right. Thank you. So what's that going to be? 1100?
Just 1
Is this
sorry, 10 over 1000.
what? Is this right? 11 over 0.01.
Maybe
It's
100.
110.
110.
0.01 is right.
Yeah.
11 over the
yeah.
is 110.
110.
Yeah.
No, I'm right.
Oh,
1,100.
1000. Sorry.
Yeah. So I'm right here. Okay, fine. Okay. And now the last part is a 2 ohm resistor is connected. What is the voltage now? So I'll just draw our picture, okay? So we have this one here we said is 10 milliohms. No, we said, what was this one? 190 milliohms. And this one here was 10 milliohms. And this one here is 220 volts. And then you connect in the question another resistor here of 2 ohms. Okay? And my question is, what is the voltage on this guy? So for example, maybe you connect like a light, for example, and that's 2 ohms. And I want to know what is the voltage here. Guys, what are you checking?
The parallel I'm checking.
Really? You need to check this?
I'm not sure I'm right. Like 1 over R.
The resistor is 1 over R, but I forgot the V. So V is plus V1 plus V2 is so V.
No, this V and this V are the same.
It's same.
Same.
Okay.
Oh, you forgot this. And you forgot this. Did you forget this?
What?
Okay. Calculate the V, please.
You will say the line V equals the resistor V.
Yeah, the V here is the same as the V here, which is also the same as the V around both of them. You remember we learned this. This voltage and this voltage are the same, and that's the same as this voltage here.
Okay.
Yeah, remember this, Ben? This is the same as this and this. They're all the same.
Okay.
Which one?
What's the I?
The I?
Yeah.
Calculated.
Yeah, I don't remember the whole I. Oh, sorry.
But it's different now.
Yeah, it's different.
This number is ugly.
So, shall we look at it? What resistance did you get here, Gao, for this one, if you add these two together?
10 over 1005.
Really?
2 over.
2 over 201.
1.
Yeah, what's as a decimal? 0 point.
Oh, I didn't simplify.
Okay, well, what is it as a decimal, please? 0 point.
0.001. Sorry.
0011?
I did all the calculate and
That's fine, but what's 2 over 201, please? Somewhere.
What's your question?
2 divided by 201. 0 point
0099.
9.95.
995?
Yeah,
Okay, so look, if I want the voltage here, I can just use my formula.
yeah. Just
over 0, 0, 0, 995 times 220.
Yeah.
It's roughly equal to 11. I think. Want to check?
What? Oh. Yeah, 11.
Hmm.
So the reason it's still 11 is because this is so big compared to this that you can still keep the voltage you got earlier of 11 volts even if you connect a light to it. So for example here, Summer, this is what you could do. If this is 11 volts,
Yeah.
then you could change this, you could make it go down to 0 volts for the light here. So you can control the light then. Yeah. So that's the called potential divider. And then that's it. That's all we needed to do for this lesson. That was the last thing in electricity, was the potential divider. Okay. So what we do is we'll start our revision. There's just one question. Just one.
This one.
Yep. Just one question. Question 1. Yeah. It's a little long. Let's do this question, and then when you when
Jay.
yeah, Jay. After this question, we'll do our revision. We'll do last year's exam.
Okay.
After this, we'll do revision. We'll look at last year's exam.
Oh.
I have to open it up.